Welcome to the Cryptography with Python class. I am Sam Bound, taught for 17 years, and I've given talks at DEF CON and other conventions, and you can reach me on the web and Twitter. Here's what the course includes. First comes obfuscation, basic ideas of what encryption is, and old-fashioned encryption techniques which hide data to make it more difficult to read, but do not really hide it from a determined adversary. And these are the basic activities of encryption modules, which are just combined in different ways to make stronger, more modern encryption techniques. Then comes hashing, which has two main purposes. The first is to put a fingerprint on a file so you can tell if it has been altered, and the other one is to conceal passwords so you can still recognize the correct password and enable login, but a person who steals the hash cannot easily recover the password from it. And then strong encryption. Encryption that conceals data even against determined adversaries like enemy military agencies and such if done correctly, the two main methods being AES and RSA, both approved by the U.S. government. You do not need to have programming experience to learn this. You don't need any special computer. Any computer that can run Python can do these projects. And you don't need much math, because we are not going to be inventing new encryption techniques. We're just learning how to use the standard ones that exist, and that doesn't require anything more than very basic algebra. So, this class covers essential cryptography concepts, the classical methods I mentioned, such as the Caesar cipher and XOR, the concepts of confusion and diffusion, which determine how strong a crypto system is, and then hiding data, hashing data, strong encryption methods, and attacks against these methods, including the padding oracle attack. Python is the best language to start with if you are a beginner. That's what makes it so popular. You can write very powerful code with just a few lines, and, especially important for our purposes, you can handle arbitrarily large integers with complete precision. Here's base 64 encoding as an example. ABC, when encoded with ASCII, turns into 24 bits of binary, interpreted as 3 8-bit bytes. But you can break it into 4 6-bit bytes, 6-bit groups, which aren't exactly bytes. And now, the 3 letters ABC turn into the 4 letters QUJD. That's base 64 encoding, and it's very commonly used. Microsoft had one of the simplest password hashing algorithms, and here it is. You take the password and turn it into Unicode, and then you hash it with the very old algorithm MD4. So this password, P@SW0RD, turns into this long hexadecimal string, which is related to the password but not in any obvious way. AES, the strongest encryption technique of the standard type private key encryption, works like this. You have a secret key that must be transmitted to both parties, the sender and the receiver, and you encrypt blocks of plain text, 128 bits at a time, into blocks of ciphertext. So this plain text, secret 16 bytes, turns into this binary blob here, and nobody can get in there without the key. That's the whole point of AES. But you can do some things without knowing the key, and one of the things you can do is the padding oracle attack. In the padding oracle attack, an attacker who does not have the key has access only to the encrypted text, and yet, if they are willing to change this value here and destroy this entire block of plain text, they can control the value of this byte over here in the plain text. And by doing this byte, an attacker can carefully craft a string and control what part of it will decrypt into, and sometimes fool a system into believing they have the key when they don't have the key. And here's the RSA algorithm. In the RSA algorithm, you publish a public key, which is a large prime number followed by an exponent, and anybody can encrypt data by just raising their message to a power modulus n, and nobody can read it except the possessor of the private key. This is easy enough to do in RSA, just a few lines of code. This small message called encrypt this message turns into this very large block of ciphertext, and this can be sent over an untrusted medium like the internet with great security, being sure that no one except the intended recipient will receive it. The RSA is public key encryption, which, despite its mathematical complexity, is essential for the modern internet.